questions 21 to 25 on the 2003 Grade 10 Cayley Math Contest. Troy and Daniela are running at constant speeds in opposite directions around a circular track. Troy completes one lap every 56 seconds and meets Daniela every 24 seconds. How many seconds does it take Daniela to complete one lap? So let's say Troy starts right here and goes in this direction, and after 24 seconds meets Daniela. So Daniela is right here. And then Troy continues in the same direction, and after 24 seconds catches up to Daniela once again. This is another 24 seconds. Now meanwhile, Daniela is going in the opposite direction. So Daniela is going this way, like that. So for Troy, in 24 seconds, he goes from this point basically to this point, correct? While going in that direction. And he completes an entire lap in 56 seconds. So 24 over 56 represents the amount of that one lap. And that is approximately going to be 3 over 7. So if one lap, let's say, was, X, in 24 seconds, he's able to complete 3/7 of the total distance around the track. Okay? So that is basically first step in our question. So Troy completes 33 over 7x of the distance around the track in 24 seconds. So now let's turn our attention to Daniela. Now Daniela is traveling in the opposite direction. So she's going like this. And eventually she will reach this point right here and meet up with Troy. Now how much time has elapsed? Well, 24 seconds. In 24 seconds, Troy goes from here to here, but then Daniela goes from that same point to that same point in the same amount of time. So Daniela in 24 seconds travels in the opposite direction. And we can label these points A and B like that. And Troy is going from A to B in the basic clockwise direction. And Daniela is going from A to B, but in a counterclockwise direction. So my question is, how much distance does Daniela travel all the way around from A to B? Well, Troy completed 3 over 7x of the distance. So the total distance, let's say, is x. So if you subtract Troy's distance, you will get Daniela's distance. Because remember, Troy is going from here to here. Daniela is going from A to B, but in the opposite direction. Their total distance is one full lap, and I've represented that as x. So this is basically 4 over 7x. That is Daniela's distance around the track that she's able to complete in 24 seconds. So 4 over 7x is the distance around the track that Daniela completes in 24 seconds. Now we want to know, basically, how much time does it take Daniela to complete one full lap? So we can basically use a simple comparison. She completes 4 over 7x of the distance in 24 seconds, as we have shown here. So we want to know if she is only concerned with x, no fractions this time, the full x, which represents the full distance around the track, how much time does it take her? And we'll just call that t. All right, no problem. We can proceed with this. You'll quickly see that these x's can cancel from both sides, so you're just left with 4 over 7 over 24 is 1 over t. You can cross multiply. 4 over 7t is 24. And therefore t is equal to 24 times 7 all over 4. And this looks like 6 times 7, which is 42. 42 seconds is how much time it takes Daniela to complete one lap around the track. And therefore the answer would be E. In the diagram, ABC is isosceles with AB equal to AC, and BC is 30. Square EFGH, which has a side length of 12, is inscribed in ABC as shown. The area of AEF in centimeters is. So let's start labeling this. What we know, the square has side length 12, so this is 12, this is 12, 12 and 12, correct? And then what else do we know? We know this whole side BC is 30. So if this is 12 and this whole thing is 30, then that means each of these will be 30 minus 12, which is 18, and then divide that in half, and that gives you 9 and 9. So that's 9 and that's 9. Correct? Now I'm going to draw a line that hopefully will help us. And it will be from A all the way down to the bottom like this. Perpendicular line like that. And that will allow us to figure out some distances using similar triangles. So this point that it touches, the bottom, I will just call Z. Okay? Now, this is the similar triangles relationship. We're going to use this big one, and you'll see that it's similar to this one. So that means that AZ over BZ is equal to EH over BH. All right? So let's see what we can get. EH is 12, BH is 9, AZ we don't know, that's what we're trying to figure out, and BZ, well, this perpendicular cuts this in half, and since it's 12, it'll be 6 on either side, so this will be 6, and that will be 6. So B to Z, from here to here, is 15. And therefore, if you solve for AZ, you'll get a value of 20. Okay? And therefore, we can now calculate AEF. AEF is this triangle right there. To calculate that area of AEF, you would basically take the entire full area of the triangle. So the big triangle, or I write big triangle, and it has letters, so we can just call it by its letters, ABC, basically. And then subtract from that the two triangles, EBH and FGC, right? You'd subtract from the big triangle, that triangle, and then this one right here. And finally, you'd have to subtract the square, which is EFGH. Okay, so here we go. ABC, 1/2 base times height. The big one, the base is 30, and the height is AZ, which we calculated as 20. And then EBH, 1/2 base times height. The base is 9, and the height is 12. FGC is pretty much identical. Base of 9, height of 12. And EFGH is a square, which would be 12 times 12, like that. So doing the math, you'd get 300 minus 1/2, and 1/2 is 1, so it'd just be 9 times 12, which is 108, and then 144 for 12 times 12. And that is 48. So number 22, the answer is D. A pyramid has a square base which has an area of 1440 centimeters squared. Each of the pyramid's triangular faces is identical and each has an area of 840 centimeters squared. The height of the pyramid in centimeters is. So here is a pyramid with a square base, and we are told that that square base has an area of 1440. So since it's square, the sides will be the same, and therefore x squared is equal to 1440, and therefore x is equal to the square root of 1440, like that. Okay, so that's the first part of the question. And then they tell you that each of these pyramids' triangular faces is identical. So this is one of its triangular faces right there. And I'll draw it a little bit on the side to avoid making this diagram messy. And I'll draw it head on so you can see it exactly the way it is. So here is one of the triangular faces. And I will just draw a perpendicular like that. And I'll label that as the height of one of these faces. And the base, of course, is x. It's pretty much like I have taken this face, that one right there, and I've just drawn it head on. So if I were to label, let's say, the h on this guy, it would be like this, like that, where that's h. I'll draw h there. Okay, so now we need to figure out what is the value for h. And that can be done because they tell you that the area of these triangular faces is 840. So area is equal to 1/2 base times height. They tell you it's 840. And then 1/2 base we know as x, and height is what we're trying to figure out. X we actually figured out was 1440, or the square root of that. So 1440 square root, and there you go. So this looks like 2 times 840, which is 1680, divided by 1440 square root is h. Okay, now we get to the final part of the question, which is trying to figure out the height of this pyramid. So this is the height right there, from the top to the center of the square. And we can complete this triangle by joining that to that side. And this is a right triangle, like that. And I'll call this height, I'll call it big H. Okay, so to figure out big H, pretty straightforward. Use Pythagoras. H squared plus this side. Now what is that side? How much is that? It's x over 2, right? Because that's the center of the square, and therefore it would basically be half the distance of a side. X over 2 squared is equal to 8 squared. All right, so that's basically how we're going to figure out the height. So let's see, we can plug in our numbers. H squared plus x is 1440 square root all over 2 squared. H squared is 1680 over 1440 square root all squared. All right, so we got 8 squared plus 1440, the square root sign disappears, over 4. 1680, I'll just leave it as a square, and then 1440 squared root squared is just 1440, like that. And then now we bring this over. We get 1680 all squared over 1440 is minus 1440 over 4. And this is 1960. And 1440 divided by 4 is 360. And that's all h squared. So 1960 minus 360 is 1600. And then therefore h would be the root of 1600, which is 40. So there you have it. 40 is the height of that pyramid, and therefore number 23, the answer is B. In how many ways can A, B, C, and D be chosen from the set 0, 1, 2, all the way up till 9, so that A is less than B, is less than C, is less than D, and A plus B plus C plus D is a multiple of 3. So before I begin, I want to teach a little bit of a primer, and that involves something known as N choose M. So this is pronounced N choose M. So what does this mean? It basically means, for example, let's say I have 4 objects in a box. I've got, I don't know, a square, a triangle, a rectangle, and a star. I've got 4 objects, and I ask you, in how many ways can you choose 2 of them? So it would be 4 choose 2. In how many ways can you choose 2 objects from these 4? Now, what does this mean? In the sense, what is it? Is it a number? Is it a decimal? So I'll show you how to do this. 4 choose 2 would be 4 factorial, all over 4 minus 2 factorial, times 2 factorial. All right? That would be how you figure this out. 4 factorial is just 4 times 3 times 2 times 1. And then 4 minus 2 is 2, and 2 factorial would be 2 times 1. And then you have another 2 factorial, 2 times 1. So the top is, looks like 4 times 3 times 2 is 24. And then the bottom looks like 2 and then 2, so that's 4. And therefore 24 divided by 4 is 6. So the original question was, in how many ways can you choose 2 objects from 4? The answer is 6. So we're going to use that later on in the question. You might have already known this. If you don't, hopefully that primer helped. So now we've got these 9 numbers, right? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right? Now, what's important is that we have to choose 4 of them, right? A, B, C, and D, such that when you add them all up, the sum is a multiple of 3. So it's very important that we look at each of these numbers as a multiple of 3 or not. So for example, is 9 a multiple of 3? Yeah, of course it is. It's 3 times 3. So it's a multiple of 3, and I'll denote that as 3n. Is 6 a multiple of 3? Sure. It's 3 times 2, so that's a 3n. 3 is a multiple of 3? Of course. Therefore, I'll call that 3n. And 0 is a multiple of 3, for example, when n is 0. Now, what about these other guys, 8 and 7 and 5, 4 and 2? They're not multiples of 3, but they're 1 less than a multiple of 3 or 1 greater. So, for example, 8 is 3n minus 1, right? Nothing, no tricks there. 7 is 3n plus 1. If that's 3n, then it's 3n plus 1. And very similarly, 5 is 3n minus 1. 4 is 3n plus 1. 2 is 3n minus 1. and 1 is 3n plus 1. Instead of calling them 0, 1, 2, 3, 4, and all that, I'm just going to refer to each of these as 3n, or 3n plus 1, or 3n minus 1. Okay? Now, the good news is that we can do even better than that, if you want to. Or you can say, you know what? I'm happy and content with this. Let me just work with this. And I think we can just work with this to avoid any further confusion. So far I think everything is clear. So now we have to choose our 4 numbers from these 10, right? Okay. So let's start our first scenario. There's several scenarios. I think there might be 1, 2, 3, 4, 5 maybe. But let's see. Our first scenario, how do I choose 4 numbers? Okay, well, I can just choose the multiples of 3, which are these guys right here. So that means, and this is where my primer comes in, from 4, I've got to choose 4. All right? From 4 numbers that are all multiples of 3, I've got to choose 4 of them. Right? From 4, I got to choose 4. So let's do that. That's 4 factorial over 4 minus 4 factorial all over 4 factorial. Well, these 4 factorials cancel them each other, and then you're just left with 1 over 0 factorial. And in case you didn't know, 0 factorial is equal to 1. So choose 4, there's only one way of doing that. And what is it? Well, you choose all 4 3n's. It's really that simple. And those numbers would be 0, 3, 6, and 9. And when you add them up, that's going to be 3 plus 6, which is 9. 9 plus 9 is 18. Sum is 18. And is the sum divisible by 3? Sure. It would be equal to 6. All right? So let's recap the question again. In how many ways can A, B, C, D be chosen from the set 0 to 9 so that A is less than B is less than C is less than D, and A plus B plus C is a multiple of 3? So far we got one such way. Okay? Now let's move on to a second scenario. Now I'm going to need to keep these guys in the picture screen. Now another way of doing this would be, of course, to choose as follows. We can choose a 3n. We can choose a 3n, because if you add those, it'll be a multiple of 3. And then I can choose a 3n plus 1, and then I can choose a number that is characterized as 3n minus 1. Okay? Why? Well, if you add these up, let's see what you get. 3n plus 3n plus 3n plus 3n, that would be 12n, correct? And then the plus 1 and minus 1 cancel each other. And therefore, is this divisible by 3? Sure it is. Got it? So, how do I do that? Now that's where our choose comes in. I want to get 2 of these guys. Well, how many do I have in my list? I've got 1, 2, 3, 4. So from 4 of those, I've got to choose 2. So from 4, choose 2. Got it? And then I want a 3n plus 1. I want a number like that. Okay, no problem. How many 3n plus 1s do I have to choose from? I've got 1 of them, 2 of them, 3 of them. So from those 3, I want to choose 1. And then very similarly, I also want to choose a 3n minus 1. Okay, how many 3n minus 1s do I have? I've got 3 of them. So from those 3, I want to choose 1. And there you go. This is going to help us figure out how many possibilities there are of that combination. So for choose 2, by this point, hopefully you're an expert. 4 factorial, 2 factorial, 2 factorial. So 3 choose 1 is 3 factorial over 2 factorial over 1 factorial. And then again you have the exact same thing. So now let's figure this out. 4 choose 2 is 6. 3 choose 1 is 3. And 3 choose 1 is 3. So we've got 6 times 3 times 3, which is 54 combinations of this kind right here. So we'll circle that, square it, I guess. All right, so I hope you're getting the hang of this. I think we've got 3 more scenarios. So let's go to the next scenario. Our next scenario would be choosing 3n plus 1, a number of that form, another 3n plus 1 number, and then a 3n minus 1, and then a 3n minus 1, like that. If you add these up, what do you get? You get 12n, and then plus 1, minus 1, minus 1. You just get 12n. And is that divisible by 3? Yes, it is. Okay, so now we got to go back. We want 3n plus 1 and 3n plus 1. So how many 3n plus 1s are there? Well, there's 1, 2, and 3, and we want 2 of them. So from 3, choose 2. So from 3, choose 2. And then we have 3n minus 1 and 3n minus 1. So we want 2 of those. How many of those do we have? We got 1, 2, and 3 of those for 3n minus 1. So therefore from those 3, we want to choose 2. And there you go. 3 choose 2 times 3 choose 2. So let's do this. This is 3 factorial over 1 factorial over 2 factorial. And this is exactly the same. So what is this in terms of numbers? This will be 3 and this will be 3, and therefore that is 9. So we got 9 more. All right. So let's keep going here. 4th scenario, and I think there's one last one, a 5th scenario. So the next scenario, we would choose, let's say, a number that's represented by 3n, and then 3n plus 1, and then 3n plus 1, and then 3n plus 1. If you add these up, you'll get 12n plus 3. Is this divisible by 3? Sure it is. It would be 4n plus 1. So that would definitely be an integer. All right, here we go. We want a 3n. We want one 3n. How many of them are there? There's 1, 2, 3, 4 of those. So from those 4, we want to choose 1. So that's 4 choose 1. And then we want 3 of these 3n plus 1s. How many 3n plus 1s are there? There's 1, 2, and 3. So from those 3, we choose 3. So 3 choose 3. Okay? And by this point, you're an expert, so I can just write down what it is. It's basically 4 and 1. So that gives me 4. 4 more combinations. And then the last possible way of getting a sum that's divisible by 3 would be 3n minus 1, 3n minus 1, 3n minus 1, and a 3n. Now add these up. You've got 12n minus 3. Is this divisible by 3? Yes, 4n minus 1. Okay, 3n minus 1. How many are there? 1, 2, 3. From those 3, we got to choose 3. So from 3, choose 3. And then we want one of these guys, 3n's, and there was 4 of them. So from 4, choose 1. And this is going to be 1 times 4, which is 4. And there you go. This is it. That's the only combinations we can possibly get. So how many do we have in total? We had 1 here, 54, so that's 55, plus 9, so that's 64, plus 4 gives me 68, and another 4 gives me 72. So 72 is the total, and therefore number 24, the answer is E. BAC is said to be laceable if distinct points x1, x2, ... until x2n can be found so that x2k minus 1 is on AC for each value of k, x2k is on AB for each value of k, and AX1 is equal to x1, x2 is equal to x2, x3 is equal to ... equals x2n minus 1, x2n is equal to x2n A. For example, the angle 20 is laceable as shown. The number of laceable acute angles whose size and degrees are integers is. Okay, well, first and foremost, we will definitely need to explain this question before we proceed with solving it. Okay. All right, so here we go. x2k minus 1 is on AC. So here is AC, right? That's AC. And x2k minus 1 is on it for each k. So whatever k is, okay, that means that basically all the odd numbers are on here, AC. And we know, we can see that is the case. The odd numbers are going to be there. That's what 2k minus 1 is. It's an odd number. Then they tell us that x2k is on AB for each value of k. So this is AB, and x2k, which are of course even numbers, are on that line. So we've got even numbers there. Okay? And then comes a very important part, which is AX1 is equal to x1, x2. So this is AX1, from A to x1. That is equal to x1, x2. This is x1, x2. That basically means that this is an isosceles triangle. Okay? And if that is an isosceles triangle, then this angle will be the same as that angle. All right? And then similarly, x1, x2 equals x2, x3. So where's x2, x3? It's right here. And therefore that means this is an isosceles triangle, so therefore this angle will be the same as that angle. And it just keeps on going here all the way until the very end, which is x2n minus 1 2n. So basically that would mean this one, the second last one basically, is equal to x2n A. x2n, and then finally back to A. So that means this is an isosceles triangle, and therefore this angle is the same as that angle. Okay? And they have told you that one possibility to make all these conditions work is 20 degrees. They want you to find how many other degree values can be used to make all these conditions work. Okay, so I hope that makes sense, at least so far. So what I'm going to do is I'm going to start filling in these angles, and using the fact that we are going to get a lot of isosceles triangles because of this condition right here. All right, so here we go. So I'm going to start with this angle right here, and I'm going to call that theta. Okay, that's my starting point. 20 is just an example that they gave us, but we need to start figuring out in terms of theta. Now we know from this very important clue, or condition I should say, that AX1 is equal to x1, x2. Okay? If that is the case, this is isosceles, and therefore this is also going to be theta, right there, that angle. So I'll put theta in there. And then we know, if you keep going, that x1, x2 is the same as x2, x3, like that. That's also going to be isosceles. So therefore, this angle has to be the same as that angle. Now this angle in here is 180 minus 2 theta, correct? Because that's theta and that's theta. So therefore this angle is got to be 2 theta, right? Because angles about the same line are the same. And therefore, since this is isosceles, that's 2 theta as well. All right, so far, so no problem. And then this angle in here has to be 180 minus 4 theta. Okay? Just for the sake of completion, this angle in here will be 3 theta, because angles about a line all add up to 180. Now, continuing with this, we know that x2, x3 is equal to x3, x4, like that. So this is now isosceles. So therefore, if this was theta, 3 theta right there, this is also 3 theta. Okay? And therefore, this angle in here is 180 minus 6 theta. And therefore, this angle in here is 4 theta. And then continuing with this relationship, we see that x3, x4 is the same as x4, x5. That's what this basically is telling us. And therefore, this is another isosceles triangle. So this angle is the same as that angle, and therefore that is also 4 theta. Okay, and therefore this angle in here is going to be 180 minus 8 theta. Now at this point, for the sake of clarity, I will put this diagram again, but a fresh version. So here's our fresh diagram. I'm going to keep both of them in the same screen. Now if you continue in this fashion, the way I did up here, you will be able to fill out all these angles in the same way that I have. Nothing fancy. All we're doing is just looking at the fact that they are isosceles triangles. The properties of isosceles triangles, that 2 of the angles are the same, and then you just subtract from 180 to get the third angle. That's all that is. Now on this, I want to concentrate on a triangle that is AX1, X2, and a triangle that is AX8, X7. So these triangles right here, this one and this one, AX8, X7, like that. Okay? And what I'm going to do is I'm going to draw a line from x2 to x7, like that. Now, I want you to look at this scenario and pay attention to the fact that this was theta, right? Just like how I filled up there. This is the same as that, so I'll draw those little lines there. And then at the very end, a to x8 is the same as x8 to x7. So those are also isosceles. And therefore this angle is also theta. Correct? And we know that this angle is also theta right here. Entirely based on the fact that these are isosceles triangles. Now that basically means that these two triangles are congruent. And those triangles are AX1, X2 and AX8, X7. They have pretty much the same angles, and therefore they are congruent. So that basically means that AX2, the distance from A to X2, is the same as the distance from A to X7. All right? So that means this distance from A to X2 is the same as the distance from A to X7, like that. And therefore, this triangle, AX2, X7, is also isosceles. And now what I want to do now is get a relationship between theta and these angles. Because AX2, X7 is isosceles, these two angles must be the same, the ones that I drew in red. So I'll call those y. And therefore, theta plus y plus y must equal 180. And therefore 2y is equal to 180 minus theta, and therefore y is equal to 180 minus theta over 2. And in a very similar way, you'll be able to show the same thing if you extend the triangle all the way to x4 and x5, like that. And you can call these z and z, and you'll see that that will also be an isosceles triangle. And therefore, in a very similar way, theta plus z is 180, and therefore 2z is equal to 180 minus theta, and therefore z is equal to 180 minus theta over 2. Now in our specific scenario, we have proven that z is 4 theta. So we can put that in there. 4 theta is equal to 180 minus theta divided by 2. And if you solve for this, you'll get 8 theta is equal to 180 minus theta, and therefore 180 is equal to 9 theta, and therefore theta is 180 divided by 9, which is 20, which is exactly what we have here. But that 20 is for this specific scenario. For a scenario where we get up to x8, x8 is our largest number. And what is x8? x8 is basically x2k, right? That's what it goes up to, or x2n. They're using x2n. So let's use x2n, like that. So that means in our example, 8 is equal to 2n, and therefore n is equal to 4. But n could be anything, right? N could be any value. It could be 8, it could be 9, it could be 10. But what's very important to remember is that n cannot be 9 or 11 because it has to be even. So that's a very important thing that must be pointed out. But then it could be any even number. It could be 4, it could be 8, and so on, right? So that's what we have to concentrate on, is not 8, we have to look at 2n. So going back to this, I want you to now concentrate on this equation right here. 4 theta is equal to 180 minus theta over 2. We are convinced that it works for our specific example when our 2n was equal to 8, and therefore n was equal to 4. But what about other values of n? For other values of n, what will this equation be? Well, think about it for just a few seconds. N is 4, correct? And what number do you have here? It's 4. So for other values of n, this will basically be n theta is equal to 180 minus theta. And I encourage you to go back and try this for other values of n. For the sake of time, I won't do it here, but if you say make n another value, then you'll see that this will match exactly the way I've done it for n equals 4. So now this is now at the heart of our problem. This will help us find values of theta. So let's work with this now. We got 2n theta is equal to 180 minus theta. 2n theta plus theta is equal to 180. Factor out the theta and you get 2n plus 1 is equal to 180. And therefore theta is equal to 180 over 2n plus 1. Okay? Now, theta is going to be our integer value of the angle, and 2n plus 1 has to therefore divide evenly into 180. And 2n plus 1, the way it's written, is an odd number. So basically we have to find odd divisors of 180. So odd divisors of 180 are 3, 5, 9, 15, and 45. For these numbers, we will basically get an integer value for theta. And those values for theta corresponding to these numbers are 60 degrees, 36 degrees, 20 degrees, 12 degrees, and 4 degrees. So we got 1, 2, 3, 4, 5 possible values for theta, where theta is an integer. And that is the answer to this question. So therefore, bringing the question back, the answer is 5, and therefore that would make 25 C.